Welcome to my kcse revision channel, Marita James Rewards Voice School. Today we are looking at Form 2 work, periodic table, kcse revision, and we are looking melting point and boiling points across the period. So we have the melting point and the boiling points across the period 3 elements. The period 3 elements we have sodium, magnesium, aluminium. Then we have silicon, which is element in group 4. We have phosphorus, sulfur, chlorine, and argon. On the above grid, these elements you can also have provided with a periodic table that the letters do not represent the actual symbols of the elements. So in the periodic 3 elements from this grid, we have element N, Q, R, S, we have element Z, P, V, and Y. So in the periodic 3 elements, how can you explain or how can you answer a question dealing with melting and boiling points? So you need to know that when answering the questions on melting and boiling points, normally use the structure and the bonding. So the structure and the bonding normally is used. So we talk of this one here as you can use this structure and you use normal structure and the bonding when you are explaining the difference in melting and boiling points across the period 3 elements. So as you can see from this grid, in period 3 are grouped, categorized into the 3 parts, where in types of bonding structure and bonding across the period. So we have between sodium and aluminium, where we have sodium, magnesium, and aluminium. This one they have a metallic structure. So we have from this region here we have metallic. This one they have metallic structures. They have the metallic structures with metallic bonding. So we have this one as metallic. So we have this as metallic bonding. So that is from sodium, magnesium, and aluminium. When you come to phosphorus, sulfur, chlorine, and argon, which are represents part of the nanometals. This one here they have simple molecular structure. So this part they have the simple molecular structure. They have simple molecular structures. The simple molecular structure, the atoms are held. Simple molecular structure, we talk of the covalent bonding. So here we have covalent. We have the covalent. We have this one as the covalent bonding, in which the atoms are held together by van der Waals forces. So here we have the van der Waals forces. So we have that one as the van der Waals forces. When you come to silicon, this silicon, the type of a structure, this one it has what we call the giant covalent structure. So we talk of this as the giant covalent structures. We have the giant covalent structures with giant covalent bonding. So we have this one as the giant covalent bonding. So you need to know that the giant covalent bonding, the atoms are held together by strong bonds, and therefore in silicon we have the highest melting point. So we have this one as the highest boiling. We have the highest boiling and melting point. So the melting point in silicon, the boiling and melting point in silicon is very high. because we have a chain covalent structure in which the atoms are held together by a strong covalent bonding. So when told now to compare the melting point of sodium and magnesium, in this case we use from sodium, magnesium, and aluminium, we use the number of the localized electrons. So here, use the number of the localized electrons. So we have number of the localized number of the localized electrons. And what do you know about this one here? The higher the number of the localized electrons, the higher the melting point. So the melting point, when you are comparing the melting point of magnesium, aluminium, and sodium, magnesium, and aluminium, so you can have sodium here, you have sodium, then we can have magnesium, and then you have aluminium in that case. So if you follow that order, there is an increase. So you talk of an increase in melting point and boiling point. The reason is because of the increase of the number of the localized electrons. Sodium has 1 localized electrons, magnesium has 2, aluminium has 3. So as the number of the localized electrons increases, the melting point and the boiling point also increases. So on this side of phosphorus, silicon, chlorine, and argon, in this part we are not using the number of the localized electrons, but we are using the size of the molecule, or what we call the atomicity. So here, from this up to here, we are using the atomicity. Atomicity, in this case, we are talking of the number of molecules. So we talk about the number of molecules. So for instance, this phosphorus is tetratomic. So we call this one is a tetra-atomic molecule. This one is a tetratomic, means that it has 4 molecules. When you come to saliva, saliva has 8 rings, so we call this one okita-atomic molecule, meaning this one has 8. When you come to chlorine, chlorine is a di. We talk of diatomic. So this one is called the diatomic, meaning this one has 2. And then we can also have the argon, which is group 8. This one is called the monoatomic molecule, which this one has 1. So the higher the number of the size of the molecules, then the higher the number of melting points. So a molecule which has high number of size of the molecules, so we have the highest melting point. So we have this one here. This one has the highest melting and boiling points, because it has the higher melting and the boiling points, because the van der Waals forces in this case is very strong. So when told to compare the melting point here, in this case, we use the number of molecules, whereby the higher the number of molecules, the higher the melting and the boiling points, because of the strong covalent bonds, the strong intermolecular forces between the structure. Kindly follow my channel, click the notification bell. You get notified once I upload a new video.